Hello everyone, welcome to our channel Code with Sunny, and in this video we'll be talking about the problems of weekly contest 3 to 4. And the first problem is going to be like we are going to talk about add edges to make decrease of all nodes even. Okay, in this video. Okay, so this problem is also related to the graph concept, like we are having the undirected graph and you need to perform a certain operation using adding edges such that you need to return true or false based on certain conditions, like if you can add at most two additional edges so that there is no repeated edges and no self loops, then we are going to return true, and such that also each degree of each node is going to be even, otherwise we are going to return false. So let's try to understand this problem in a detail. Okay, so let me just go to the editor as well. Okay, so you're having an undirected graph, and remember you are having only at most two operations. So okay, so your operations is going to be less than or equal to 2. Okay, and you can add like the in one operation you can add an edge between two nodes. In one operation you can add an edge between two nodes, and after doing at most two operation you need to make sure that all nodes have even degree. Okay, so all nodes should must have the even degree. Okay, let's try to take an example and let's try to understand this. Suppose we have this one, and also you need to return true or false based on the condition that if you are able to do this in at most two operation, if you are able to make all nodes of the graph as even, then you can return true. So we have this 3 and we have this 2 and we have this 5. Okay, now let's try to find out the degree of each node. You can see the degree of this node is 2, degree of this node is 4, so degree of this node is going to be 3, degree of this node is going to be 2, and degree of this 5 is going to be 1. Okay, now it is obvious that for all nodes which have the degree as even, we are not going to disturb that. Okay, because if you are going to disturb it right now, then it would be like a lot more difficulties to make all the nodes as even. Okay, suppose we got a set which contains all nodes which have uh, odd degree. Okay, now you can see this is going to be the set, and let's say the size of the set is sz. Okay, so sz must be a multiple of 2. If you are not aware about the concept of the graph, undirected graph, in with the respect of degree, you can check out on the internet also. The size of the the set which contains all nodes must have a which contains odd degree, the size of that set is going to be a multiple of 2. Okay, so size sz can be 0, it can be 1, it cannot be 1, I'm really sorry. It is going to be 2, it is going to be 4, it can be 6, it can be 8, or so on. Okay, now one thing that should be that you can notice over here, if the sz size of the sz is going to be greater than 4, answer will always be false. Okay, why this is going to be a valid condition? Because if the size of the set which contains all the nodes which have odd degree is going to be greater than 4, you cannot make all the nodes which have degree as even in two operations. Okay, suppose you have these let's say you have 6 nodes, it is something like this, and you have only two operations. In one operation you can join just these two nodes, in another operation you can join these two nodes. Okay, when you join these two nodes, each node degree will be incremented by 1, so this will be also incremented by 1. So all the nodes here, 4 nodes, will have degree as even. Okay, now these two nodes will remain as it is, so their degree will be odd, so you cannot convert all the nodes to its even degree. Okay, so if sz is greater than 4, then your answer will be false, because you cannot convert all the nodes which have odd degree into even in at most two operations. Okay, now there are only few cases to deal with. Okay, So we have sz equal to 0, and we have sz equal to 2, and we have sz equal to 4. Okay, and one thing that you should also notice over here is uh, you can add at most 2 additional edges so that there are no repeated edges and no self loops. Okay, so repeated edges concept is something like this. If you have already a node, if you have already a edge between node A and node B, you cannot add another edge, something like this. And a self loop is something like this. If you have a node A, then you cannot add a edge between node A to node A. So this is a self loop. So you need to try to avoid adding edges in such a way that there are no repeated edges and no self loops. Okay, so when size is 0 means there are no nodes that have odd degree. In that case you need to return false. Okay, so let's talk about size equal to 4. Okay, so we have these 4 nodes A, B, C, D. Okay, so you need to just check it out if you can add edge between the nodes efficiently. So you have to check all the conditions. So your first condition is you're trying to add a node between add a edge between A comma B, and add a edge between C comma D. The other case is you need to add a edge between A comma C, and add a edge between A comma B comma D. And the third case is going to be you're going to add a edge between A comma D, and the other is going to be B comma C. Okay, so these are the 3 cases that you need to consider. Okay, so if like when you are just considering these 3 cases, you need to also check that A and B must not be neighbor. So if node A and node B are already neighbors in the original graph, and if you're adding another edge, it will create a repeated edges. Okay, so you need to avoid this condition. So what are the things that you need to check? If any of the 3 conditions, any of 3 condition is true, if any of the 3 condition is true, you should return true. And like how to check the conditions? If you're adding edge between node A and node B, and node C and node D, you need to check whether like you need to confirm that node A and node B are not neighbors in the original graph, node C and node D are not neighbors in the original graph. Similarly, if you're checking between A and C, node A and C should not be a neighbor, and node B and D should not be a neighbor. Note that this is the and, there is an and condition between this one. So if you're checking a A and B pair and C and D, so node A and B should not be neighbor, and node C and D should not be the neighbors in the original graph. If any of the 3 condition is true, you are done, you are going to return true. Okay, so let's try to talk about sz equal to 2. Okay, so you have only 2 nodes. Okay, so one of the case is the same as the previous one. You are going to check if you are able to add an edge between node A and node B, node A and node B, if they are not neighbors. They are not neighbors. Okay, so you are going to check if you are able to add a node between node A and node A and node B, and A and B should not be the neighbors in the original graph, then you are done. Then you are going to return true. Okay, now there is one more case. Like I have with all the conditions that I have told you right now up to so far yet, like when I have just implemented that and I submitted it, I get a wrong answer. Then I thought about a lot this concept sz equal to 2. Then I get one more condition. Like suppose you have this node A. Let me write down over here. We have this node A and we have this node B, and this has a odd degree, and this has a odd degree. And suppose we have a set of another nodes like which have even degrees. Suppose we have this node, this node, this node, this node, this node, and all have even degree. All have even degree. Okay, and remember we have only 2 operations. We have 2 operations. Okay. Okay, so in the previous case, like we can just check it out by adding A and B, so it cost me one operations. Okay, and we just check it out. If we are able to do that, then we return true. Now we have two operations, right? Actually we have two operations. Okay, so suppose adding A and B is not good, like it is going to, like A and B are neighbors and we cannot add between A and B. So since we have two operations, what we will try to do is we try to convert an even degree node to an odd degree node. Okay, so when you try to add a node between, sorry, add an edge between this and this, when you try to do that, this node, let me write down, let me change the color and try to denote it. Wait a minute, I don't know why it is happening. Okay, so becomes even, becomes odd degree. Okay, becomes odd degree, and this node becomes even degree. Okay, so actually what has been happened is, like we have this node A, we have this node B, and we have this node D, and this is even degree, and these two are actually odd degrees. Okay, so whenever we'll try to add a node, add an edge between two nodes, their degrees will be flipped, the parity of degrees will be flipped. So when we add this one, it becomes odd and it becomes even. Okay, now again we have this as an odd degree node and this as an odd degree node. Okay, so again one operation has been done, we have one more operation being left. Then we will try to use that operation. Can we add B and D? Can we have B and D? Can we add B and D such that B and D are not neighbors? It will cost me one operation, both are odd degree. Whenever we try to add an edge between B and D, it becomes, both nodes becomes even degree. Okay, similarly what we will do is we will try to add B as well as D. We'll try to convert an even degree node to an odd degree node, and then this becomes odd degree and this becomes even degree, and we try to add between A, this is also an odd degree. We'll try to add between, and if this is possible, if A and D are not neighbors, like they will become even after adding an edge, so all the nodes will become even. So we have only two conditions for size equal to 2. Can we add an edge between A and B? If they are not neighbors, if yes, then we will return true. Otherwise we can convert an even degree node to an odd degree node, and we'll try to check it out if we can add an edge between that even degree node, which was previously even degree and now it is odd degree, between that node and the new node B. Okay, and we have two cases, we need to consider for A as well as we need to consider for B. So let's try to check it out through the code. It will be much more better for you to understand through the code as well. So what I have done is I have taken the degree, stored the degree in a vector, and also we have the adjacency list. We have just populated the degree of each node, and we have also inserted in the adjacency list also. Note that it is a set type of adjacency list, so each node will be having the neighbors stored in the set. So we have this odd edges which will actually store those nodes which have odd degrees. So if degree is odd, we just push back that node into this vector. So if size is greater than 4, we cannot perform anything. So like we cannot convert all the nodes to an even degree node, so we'll return false. If size is 0, we are done, we return true. So if size is 2, this is a separate case. Okay, so give me a minute. Yeah, so if size is 2, so this is the case that you need to consider. So if size is not 2, then we will consider for size equal to 4. Now you can see we have three cases. Like we will try to add between this A and B and with remaining C and D. Okay, like we have three cases as we have discussed so far. Like over here we have ABCD, ACBD and ADBC, and we need to check they should not be the neighbors. Okay, so we will just check it out. Since we have adjacency list where each node has its neighbors stored in the set, we will just check it out. We will just try to find if that node is present as a neighbor to the current node odd edges of 0. Like suppose we have A comma B, so I will check B is a neighbor of A or not. So I will check the whether B is present in the adjacency list of A or not. Okay, similarly I need to check this one also. If they are not neighbors, we can just easily add and we'll just return true. Similarly, we have to check for all the three cases. And now we need to check for size equal to 2. Okay, now this is simple. You have this a and b. You need to check if we can add it. So we will check if they are not neighbors. So we are done. Otherwise, we'll try to iterate through all the nodes and we'll check it out if I is not equal to the current node. Suppose we have this a and b. Okay, we have this a and b, and we have this d also. So d should not be equal to a, as well as degree of d should be even. So we'll try to convert an even degree node to an odd degree node first, and we'll try to check if degree is even and if d is not equal to a, like a and d are not equal. So we have converted this a we have converted this d to odd degree node, because a is not equal to d, so we are just adding the edge. So a becomes an even degree, d becomes an odd degree. Then we will try to check if we are able to add the edge between the node d and node b. Like if you are able to add an edge between node d and node b, then we are done. If you are able to do that, like if they are not neighbors, we'll return true, because it cost me 2 operations. Similarly, we are going to check for, like we are just adding the edge initially between a and d. So we have to check for by adding the edge between d and b also, d and b. And then we will try to check if the like a and d are not neighbors. We have to consider for 2 cases. Okay, so this will give you all test cases passed, I think. So let's submit this code and check it out. Okay, here you can see all the test cases are passed. So if you have any doubts, you can reach out to me through the comment section of the video. And thank you for watching this video, and do not forget to subscribe.